In this video, we're going to be looking at arc length. And what I want to start off with is looking at this definition of radian measure, theta equals S over R. And I want to solve this equation for S, the arc length. So if I multiply both sides of my equation by R, my R's will cancel on the right-hand side. So I have arc length of S equals to R theta, or S equals R theta. And that is this formula that's here on your reference sheet. And you need to be sure that you remember that when you're using this formula, theta has to be in radians. Okay, our first problem, determine the length of the arc in terms of pi, then round your answer to 2 decimal places. So here's my formula, S equals R theta. S is what we're looking for. R we're given to be 6 inches, and my theta has to be in terms of radians. And right now it's in degrees. So I need to take 120 degrees, multiply that by pi over 180 in order to change it from degrees to radians. And this is 2 pi over 3. So that's my theta that goes into my formula here. I can put this into my calculator, 6 times 2/3. And if you have a graphing calculator like this, I would put this in my calculator as 6 times 2 divided by 3. If you want to use that fraction template, you can. To me, it's easier just to put it in as a division problem. And if it ends up being a decimal, then you would press math and then enter twice to change from a decimal to a fraction. Here it's a whole number. I have 4. But remember, I didn't put in the pi symbol. So this is going to be 4 pi. You have to stick that pi symbol in on your own. This is my answer in terms of pi. And then when I want to round that to the nearest hundredths place, right, 2 decimal places. So I multiply my answer here times pi, and I get 12.57. Yeah, I'm going to skip problem 2 on my handout because it is just like problem 1, except that I don't have a picture. It's just all that information just written out. All right, problem 3 says I have a pendulum swings through an angle of 40 degrees each second. If the pendulum is 20 inches long, how far does its tip move each second? Round to 2 decimal places. So I have this pendulum. That's gonna sweep out this angle here of 40 degrees. If I were to look at this whole angle that it sweeps out, that's a 40-degree angle, and I want to know this distance. Well, this is my formula for the arc length. S equals R theta. So this arc length is going to be 20 times this angle measure of theta. And again, that theta has to be in terms of pi. So I take 40 degrees, multiply that by pi over 180. That's going to give me 2 pi over 9. That's my angle measure in radians. So 20 times 2 pi over 9. So that's going to be 40 pi over 9. If I want my answer rounded to 2 decimal places, I'm going to get 13.96 inches. Problem 4, the hour hand of a clock moves from 12 to 9 o'clock, or 3/4 of a complete revolution. Through how many degrees does it move? through how many radians does it move? Right, so here's my clock. 12 is up here, and 3, 6, 9. And we're moving from 12 to 9, and I want to know this angle measure. It's 3/4 of a revolution. I want to know that angle measure in degrees and in radians. Now, be careful with this problem. Now, the first few problems that I've done have been asking for the arc length. This problem is not asking for an arc length. It's just asking for that angle measure. And I need that angle measure in degrees and in radians. And I'm told that I have 3/4 of a revolution. Well, when I'm in degrees, I know that all the way around the circle is 360 degrees. I have 3/4 of that. So 3/4 of 360 is going to be 270 degrees. If I'm in radians, I know that all the way around this circle or this clock is 2 pi radians. So I have 3/4 of that. So 3/4 of 2 pi is going to give me 3 pi over 2. Problem 5, find the positive radian measure of the angle that the second hand of a clock moves through 42 seconds. There's more than one way to do this problem, but the way that I like to think about this is that all the way around the clock, it's going to be 60 seconds for that second hand. So all the way around the clock is 60 seconds, and I have 42 60ths of a revolution. And I multiply that by 2 pi because this is all the way around. This is the part way around, and this is all the way around. So when I multiply that, I have 7 pi over 5. Problem 6, find the positive radian measure of the angle that the second hand of a clock moves through in 8 minutes and 40 seconds. And there's more than one way to do this problem. The way that I want to do this problem is I'm going to break this up into these 8 minutes and then 40 seconds and find each of those radian measures separately and then add them together. Right? I'm looking at how many times the second hand goes around in 8 minutes and 40 seconds. So the second hand is going to go all the way around this clock 8 times. So for those 8 minutes, I have 8 full rotations. So I have 8 times 2 pi, which is 16 pi. For the 40 seconds, that's only a partial rotation. So I have 40 60ths of 2 pi. It goes all the way around is 60 seconds. I have 40 60ths of that. So that multiplies to give me 4 pi over 3. Now, another way that I could do this problem for the 40 seconds part is to know that 40 seconds would put my second hand over here at 8, and that's 8/12 of a revolution. So I could say this is 8/12 times 2 pi, multiply that, and I would get 4 pi over 3. So either way I do this 40 seconds, I get 4 pi over 3. Now I just need to add these two together, 16 pi plus 4 pi over 3, and that will give me my total angle measure, 52 pi over 3. Okay, problem 7. The minute hand of a clock is 6 inches long and moves from 12 to 7 o'clock. And you see I have some question marks here. I'm going to come back to that in just a second. Okay, minute hand is 6 inches long. It moves from 12 o'clock to 7 o'clock. How far does the tip of the hand move? Write your answer in terms of pi, then round your answer to 2 decimal places. And this problem is asking me to determine the arc length. So I know that my arc length formula is going to be S equals R theta. And I know that my radius, or R, is 6. I just need to figure out that theta. Now, this kind of goes back to what this little question mark is about. Now, my problem says that my minute hand is moving from 12 to 7 o'clock. Now, I think what the book is wanting you to do is technically incorrect. And let me explain what the book is asking you to do, or my math lab is asking. My math lab is saying that this minute hand is going from 12 to 7, and it's saying it's going 7/12 of a revolution. Well, actually, your minute hand, if it's going from 12 o'clock to 7 o'clock, your minute hand is going around this clock 7 full rotations, so 7 times 2 pi. So I think that technically this is incorrect. If this would have said hour hand, I think that this would have been correct, right? So if it goes from 12 to 7, that is 7/12 of a revolution. So my theta would be 7/12 of 2 pi, which is going to be 7 pi over 6. So my theta is 7 pi over 6. So that's going to be 7 pi inches. And rounding that, I get approximately 21.99 inches. So one of the things I want to mention is about why I wanted to keep this problem in your homework assignment, even though I feel like it's technically incorrect. And one of the reasons is this is what I call a classic math problem. I think it's a very interesting math problem, but this problem was in my textbook 40 years ago when I was in trigonometry in high school, and it's probably going to be in trigonometry books 40 years from now. So it's a very interesting problem if they would have just written it correctly. But a second reason why I wanted to put this problem in here with this mistake in it is for those of you who are going to be future math teachers or science teachers, you need to know that sometimes your textbooks are wrong. They're made by humans and humans make mistakes. Right. Problem 8, the minute hand of a clock is 6 inches long. How far does the tip of the minute hand move in 40 minutes and round to 2 decimal places? So I could think about this 40 minutes as being 40/60ths of a circle or 8/12 of a circle. We saw that same problem earlier. So S is going to be R theta. S is going to be 6 times theta. Theta at 40 minutes is 40/60ths of a revolution. So multiply that by 2 pi. And I get 4 pi over 3. And so that's my angle measured in radians. So this is 8 pi inches, which is approximately 25.13 inches. Okay, problem 9. The radius of a wheel rolling on the ground is 75 centimeters. If the wheel rotates through an angle of 60 degrees, how many centimeters does it move? And express your answer in terms of pi, and then round your answer to 2 decimal places. So here is a picture of my wheel. And let's say that my wheel is rolling in this direction. So it's going to follow this path right here. This distance that the wheel moves is equal to this distance curved right here. So I'm looking at this angle, which I'm told is 60 degrees, and I'm told the radius is 75 centimeters. This arc length is equal to this distance that the wheel is moving on the ground. So S is equal to R theta. So S is equal to 75 times that angle measure, 60 degrees. But 60 degrees needs to be changed into radians. So multiply that by pi over 180. I get pi over 3. So that arc length is 25 pi centimeters, and that is approximately 78.54 centimeters. Okay, problem 10, an automobile is pushed so that its wheels turns 3/4 of a revolution. If the tires have a radius of 14 inches, how many inches does the car move? So again, here's my formula, S equals R theta. So S equals 14 times that angle measure of theta. It's 3/4 of a revolution. So 3/4 of 2 pi is 3 pi over 2. So now that I have my angle measure, I can multiply this out and get 21 pi, which is approximately 65.97 inches. Problem 11. A circle has a radius of 4 feet. Find the area of the sector formed by a central angle of 60 degrees. Determine the area of the sector in terms of pi, then round your answer to 2 decimal places. All right, so we're dealing with a different problem here. We're dealing with area, not arc length anymore. Your formula for the area of a sector is here. Area is 1/2 r squared theta. And again, theta needs to be in radians when you're using this formula. So I have 4 squared times my theta, and theta is 60 degrees. So multiply that by pi over 180, and that gives me pi over 3. So put that into my formula. Multiply all of this. I have 8 pi over 3, and that unit is feet squared. When I put this in the calculator and round it to the nearest hundredth, round it to 2 decimal places, my area is going to give me approximately 8.38 square feet.